Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, and in this video, we are going to present about our campus hospital network design. Before we start, this is my group members. The first one is Amrul, the second one is Aina, the third members is Nurif, the fourth members is Harun, and lastly, me, I'm your admin.
So, in this image here is our campus network of Tembila Hospital Design. Okay, so in this plan of ours, there will be 12 access points with their area of coverage, 6 switches and 2 routers, all are connected by the local area network cable, which is the LAN cable. And today I'm going to present the location of server room and its justifications. In this project, we're going to place the server room centrally, and the first reason of that is this leads to reduced cable length. The shorter the length of the cable, the better the network performance. The shorter cable length reduce signal attenuation and improve the overall efficiency of the network. The second justification is simplified network management. The IT staff can more efficiently monitor, troubleshoot, and upgrade the equipment when it is located in a centralized and accessible location. The third justification is security and access control. Access control, surveillance, and the other security features can be concentrated in one place, in one location, enhancing the overall security of the IT infrastructure. The last one is optimized use of space. Centralized server rooms allow for better space utilization. The layout can be designed for efficient rack placement, cable management, and overall organization, making the most of available space.
Next, location of routers and switches and their justifications. Hospitals often require redundant network configurations to ensure continuous operation. Well-placed routers and switches contribute to high availability by providing redundant path and failover capabilities. The location of routers and switches in a network infrastructure is important and can significantly impact the overall performance, efficiency, and reliability of the network. In this plan, we place the routers and switches strategically near the critical locations such as the main entrance, main patient registration, ER registration, X-ray room, ultrasound room, nuclear medicine room, and MRI. These locations are crucial because it requires the reliance of network connectivity such as electronic health records and medical imaging. The placement of routers and switches should support low latency communication to ensure timely information exchange among the healthcare departments. Well-placed routers and switches ensure that these devices have reliable connections and contribute to patient safety. Radiology departments and diagnostic imaging services heavily depend on high-performance networks. During emergency or urgent situations, quick and reliable access to patient data, diagnostic information, and communication system is essential. So, well-placed routers and switches contribute to responsiveness of the network in the emergency scenarios. Routers can be configured to support network redundancy by having multiple paths or routes to reach a destination. If a server is connected to the network through multiple routers or paths, and one path fails, the router can automatically reroute traffic through an alternative path, helping to maintain network connectivity. Placing routers near the patient registration and ER room are important for continuous monitoring of vital signs and rely on network connectivity. Well-placed routers and switches ensure that these devices have reliable connections and contribute to patient safety. Router placement within the critical departments are for backup in case the server goes down. Routers responsible for directing traffic to other alternative routes. Locating the switches near departments that consist of a lot of devices are crucial to ensure efficient transmission of large medical images without latency or disruptions and ensuring optimal coverage and connectivity within the department. In departments like MRI, X-ray, and ER, there is a multitude of devices that need to be connected to the network, including computers, medical imaging equipment, printers, and communication devices. Switches provide the necessary ports to accommodate and connect these devices.
Okay, for the next part, location of wireless access point and their justifications. Coverage and signal strength. Wireless access points should be strategically located to provide optimal coverage throughout the entire facility, ensuring a strong and reliable Wi-Fi signal in all areas. This may involve a combination of placing access points in central locations and near areas with high user density. Second one, high traffic areas. Identify and prioritize high traffic areas where users are likely to require wireless connectivity. Placing access points in these locations helps ensure a consistent and high-quality wireless experience for users. For example, waiting rooms, lobbies, and cafeterias in the hospital. The third one, avoid interference. Care should be taken to avoid interference from physical obstacles such as walls, large metal objects, and also electronic interference from other devices. Conducting a site survey to identify potential sources of interference can help optimize the placement of access points. Next, capacity planning. Consider the number of devices that will be connecting to the wireless network in different areas. Access points should be distributed to accommodate the expected device density, especially in locations with a high concentration of users or IoT devices. For example, diagnosis imaging and operating areas because they use devices such as X-ray, MRI, CT scan, surgical robots, and monitors. Then, building layout and construction. The physical layout and construction materials of the building can affect wireless signal propagation. Adjust the placement of access point based on the building's characteristics to ensure the signal strength is sufficient and consistent. Redundancy and load balancing. Incorporate redundancy by deploying more access points than strictly necessary to ensure coverage in case of failures. Additionally, use load balancing techniques to distribute network traffic evenly across access points, optimizing performance such as registration area.
Next, I'm going to present the cabling and the types of cables used at each connection. So the two types of cable we are going to use is Cat6 and Cat6A. The first connection is switch to router. These cables provide the necessary bandwidth for data transfer between the local network and the wider network, such as the internet. The second one is switch to access points. Cat6 or Cat6A cables are often suitable for this connection, especially if high-speed data transfer is needed for wireless access points. The last one is server room to switches. These two cables offer high data transfer rates and are suitable for connecting high-performance devices.
Assalamualaikum. My name is Muhammad Nazir bin Najadi, and I will explain about indication of part of the network that need triple redundancy and justification of it. Firstly, let's learn about what is network redundancy and triple redundancy. Network redundancy is the process of providing multiple paths for traffic so that the data can keep flowing even in the event of failure. Next, triple redundancy refer to a specific type of hardware redundancy where three identical components are used to perform the same task with a voting mechanism to determine the correct output. This approach provides a high level of fault tolerance, meaning the system can continue operating even if one of the components fails. Now, let's see which part of the network that need triple redundancy. Firstly, server. A main server or an infrastructure that supports essential business operation. A failure could result in data loss or server service disruption. Triple redundancy can be implemented by having redundant power and cooling system within the server room. Next, router. This device forms the backbone of the network, handling a significant amount of traffic and routing data between different network segments. Their failure could cause widespread outage and disruption. Finally, is switch. Switch will connect multiple network segments, ensuring efficient data flow within the network. Their failure could isolate large portion of the network, leading to significant downtime.
So let's go to the price of the proposed computer network solution and complete detailed cost and the justification of each device proposed. So first, wireless access point or WAPs. We chose Aruba IAP 205RW wireless network access point 802.11 AC 867 Mbps. The price per unit is RM 800 plus, and the total cost for 12 WAPs is around RM 9700 above. The reason we chose this access point or this brand, it is a reliable brand, robust for critical applications, support high device density in hospitals, cost-effective units, centralized management, and it ensures seamless Wi-Fi for medical equipment and staff devices. It also handles crowded areas effectively, save budget without compromising quality, easy control and updates from one platform. Next, let's go to the switches. We chose HPE Aruba Networking CX 6300 M24 port, 1 GBE class for PoE and 4 port SFP56 switch. The price per unit is 35,160 plus. The total cost for 6 switches is RM 211,000. And the reason we chose this is because we prioritize the HP Aruba switch for its high performance connectivity, robust security and seamless integration with our existing Aruba ecosystem. This also ensure that critical medical applications, patient data protection and efficient network management aligning perfectly with the hospital needs. Let's go to the routers. We chose Nighthawk RAX50 dual band AX6 Wi-Fi 6 router. The price per unit is 1,200 above. The total cost for 2 routers is around RM 2,518. The reason we chose this model is because it is the latest Wi-Fi 6 technology for faster speeds and reduced latency, ideal for demanding hospital application. Dual band for separate channel optimizing medical and personal needs. Reliable and secure for patient data protection. Blazing fast Wi-Fi for real-time data and high-definition video. Dedicated channels for smooth performance even with mixed traffic. Renowned Nighthawk reliability and advanced security features. And lastly, the server. We chose PowerEdge R750 rack server. The price is a bit costly, which is RM 29,353.50 per unit. The total cost for this is the same, which is RM 29,000 plus. The reason we chose this is because it is critical. It can be useful for critical hospital applications like EHR and imaging systems, scalable and flexible to grow with the hospital needs. There's renowned reliability and uptime for continuous access, comprehensive security safeguard, sensitive patient information. It is also can handle demanding software with ease, now and in the future. Adapts to your growing data requirement and also minimize downtime for uninterrupted patient care. Robust security features comply with healthcare regulations. So, With that, the total cost for all of the network equipment approximately around RM 252,502, excluding cabling, installation, and software license.
So, in conclusion, we have designed a campus hospital network that followed the requirements such as all documentation, such as doctor's notes, prescription, and patient information will be stored online, and the online system can be accessed by the doctor and nurse using a portable computer that connects to the hospital network wirelessly. And we also have planned a specific and suitable location for each devices and a specific cable for network connectivity based on the department's needs. So that's all from our group. Thank you.